The next one is an or question. What's the probability that a person owns a raincoat or an umbrella? The rule for or questions, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. We are told what all of those probabilities are. The probability of owning a raincoat is 0.54. The probability of owning an umbrella is 0.35. The probability of owning a raincoat and an umbrella is 0.11. So we just have to put those numbers into the rule and calculate 0.54 plus 0.35 minus 0.11 equals 0.78. Number 11, suppose 20% of all elephants write poetry. And if you think of that in probability terms, that means the probability that a randomly selected elephant is one of the ones who writes poetry would be 20% or 0.2. If you meet two elephants, what's the probability that at least one writes poetry? There's more than one way we could figure this out. One way would be to think, well, for at least one to write poetry, that means that might be one but not the other, might be both of them. It's anything except the case where both of them do not. So at least one does is the opposite or complement of the situation where both of them do not write poetry. So the probability that both elephants do not write poetry, that is, the first one does not and the second one does not, would be 0.80 times 0.80. Remember, each one has a 0.20 chance that they do write poetry, so a 0.80 chance that they do not. So when you calculate 1 minus 0.80 times 0.80, it comes out to 0.36. Another way we could figure this out is to think of it as a binomial probability situation. N would be 2, we've got two elephants. P would be 0.20, there's a 20% or 0.20 probability for each one that that elephant does write poetry. And we want the probability that out of those two elephants, at least one, maybe just one, maybe both, write poetry. So this is a binomial probability question with n equal to 2, p equal to 0.20, and x equal to at least 1, which means it could be 1 or it could be 2. So you can look up both of those probabilities on table B, add them together, and get 0.36. If you meet 4 elephants, what's the probability that all 4 of them write poetry? You could also treat this one as a binomial probability question. This time n would be 4, p would still be 0.20, and for all 4 of them to write poetry, that means x equals 4, 4 out of 4. So you could look that up on table B, or you could calculate it by treating it as an and question. All 4 of them write poetry means that the first one does, and the second one does, and the third one does, and the fourth one does. So you would be multiplying 0.20 times 0.20 times 0.20 times 0.20. That comes out to be 0.0016. If you looked it up on table B, it would come up as 0.002 because they only give 3 digits after the decimal point, but that's close enough. The students in an algebra class are categorized as follows. So some of them are male and some are female. Some are freshmen and some are sophomores. And I've done some adding here, and there are 29 students in all. So the probability that a student selected at random is male, you just count how many males out of how many there are in all. So when you pick one of those 29 students, the probability that the one you pick is male would be 12 out of 29. So you can either write that as a fraction, 12/29, or in decimal form, it would be 0.414. The probability that a student is a female or a sophomore. Well, the answer is 20 over 29. And there are two different ways you could figure that out. One way would be to just go through and count how many of these students fit that description. These 9 male freshmen do not count, but these 10 female freshmen do. They're female, so they count as being female or sophomore. These 3 male sophomores count, and these 7 female sophomores count. So altogether, that's 10 plus 3 plus 7, 20 out of 29. The other way is to say the probability of picking someone who's female or sophomore equals the probability of them being female, which is 17 out of 29, plus the probability of them being a sophomore, which is 10 out of 29, minus the probability of them being female and sophomore, which is 7 out of 29. We have to subtract that because otherwise we'd be counting those female sophomores twice, once when we counted the females and once when we counted the sophomores. The probability that a student selected at random is male and a freshman, that is a male freshman, would just be 9 out of 29 because there are 9 students who are both male and freshman out of 29 in all. And the probability that a student is a sophomore, given that she is female. So when it says given that she is female, that means we're told that the student you select is one of the females. So we don't care about the males. We know that the student is a female, so we know that they're one of these 17. So out of those, the probability that the student is a sophomore, given that she's female, is 7 out of those 17. 7/17 or 0.412. And number 13 is a conditional probability question because it's asking about the probability of something being true if something else is true. The probability of a student taking Chem 2 if that student takes Chem 1. And the formula for that is we take the probability of both of those things being true, the student taking Chem 1 and Chem 2, divided by the probability of the if part, the condition, taking Chem 1. Number 14, a $20 bill, 5 $10 bills, and 14 $1 bills are placed in a bag, and you draw one bill at random. First, construct a probability distribution for the dollar amount you would win. So a probability distribution has 2 parts to it. First, it's got a list of those dollar amounts. The dollar amounts you could win are, you could win $20, you could win $10, or you could win $1. And then the second part of the distribution is a list of the probabilities that go with each one. Remember, a probability has to be between 0 and 1, and if you add the probabilities up together, they have to add up to exactly 1. So we have to figure out the probabilities. Notice there are 20 bills in all. There's 1 20, 5 10s, and 14 1s, so 20 in all. So there's 20 possible outcomes for pulling out one of those bills at random. And only one of those out of 20 is where you get the $20 bill, where you win $20. So the probability for that is 1 over 20 or 0.05. The probability of winning $10 is 5 over 20 or 0.25, and the probability of winning $1 is 14 over 20 or 0.70, and those do add up to 1. So there is the probability distribution. To calculate the mathematical expectation or expected value, you multiply each dollar amount times the probability that goes with it and add those together. 20 times 0.05 plus 10 times 0.25 plus 1 times 0.7, that adds up to 4.2, And if you just wrote it as 4.2, you wouldn't be wrong, but it represents a dollar amount. So it's kind of weird to write it that way. It makes more sense to write it as $4.20, $4.20. So if you had to pay $4.50 for something that wins you back on the average $4.20, in the long run, you're going to be losing money. You're going to be losing an average of 30 cents a game. Here's another probability distribution, and here we are being asked to find the mean and the standard deviation. The formula for the mean looks like this, but you have to know what that's telling you to do. It's telling you to add up x times p of x. So for each number for x, we multiply that number times the probability of that x, and then add those together. So we're doing 0 times 0.16 plus 1 times 0.4 plus 2 times 0.3 plus 3 times 0.11 plus 4 times 0.03, and that comes out to be 1.45. Your mean should always be somewhere in the middle of the x values. And for the standard deviation, what this is telling us to do is add up x squared times p of x, then subtract the mean squared, and then take the square root. So we take 0 squared times 0.16, plus 1 squared times 0.4, plus 2 squared times 0.3, plus 3 squared times 0.11, plus 4 squared times 0.03. Then we subtract 1.45 squared, and finally we take the square root of the result, and that ends up being about 0.98. So that is the standard deviation. Suppose 40% of all public restrooms have hot air hand dryers. What is the probability that if 11 are selected randomly, exactly 6 of them will have those hot air hand dryers? So here it's asking for the probability of something happening 6 out of 11 times, where there's a 40% chance, a 0.40 probability of it happening on each of those possible times. This is binomial probability, and you can find that either by using table B from the back of the book, or if you have a graphing calculator, you can use the binom PDF function, or you can use the binomial probability formula. However you do it, it should come out to be 0.147. And then number 17 is also binomial probability. This time we're talking about a group of 50, so that's n, and each one has a 0.62 probability that that particular cow can dance. And it's asking for the mean. The formula for the mean for a binomial distribution is n times p. So here that would just be 50 times 0.62, which is 31. So in your average group of 50 cows, an average of 31 of them can dance. To find the variance, you would take n times p times q, and remember q is 1 minus whatever p is. So 1 minus 0.62 is 0.38. So when you multiply those together, you end up with 11.78, and then the standard deviation is the square root of that number, which comes out to about 3.4. Okay, I'm going to end this video here and come back in the next part, starting in number 18.